All right, let's do this. We have simplifying rational expressions, and then we're also going to multiply and divide. So, it is crucial that you understand how to factor to be successful in this chapter. So, in the very first problem, we see that we have 4x on top, but the bottom can be simplified. So what you would do for the denominator here is we would first factor out a 4, leaving us with an x squared plus 5x plus 6, which can then be factored again. So after you simplify, you're going to have 4x over 4 times x plus 3 and x plus 2. Now that we have that simplified, anything that's the same on top and bottom can be canceled. So in this case, the only thing we can cancel are the 4's in front. So your final answer for this first problem is x over, and you will leave it in factored form, x plus 3 and x plus 2. Okay, that's how you simplify. So this next example right here, we have to factor twice. You must factor on the top and the bottom. So what we're going to do is the top can be factored to x plus 2 and x plus 1. And the denominator can be factored to x minus 4 and x minus 1. Now you look at the top and bottom and you see that there is nothing that is the exact same. So your parentheses would have to have an x plus 2 and an x plus 2, or an x minus 1 and an x minus 1, but all 4 are different. So sometimes they can't be simplified at all. And then we will continue, and we will get to some examples where it will, like this one right here. If we factor the top, you're going to have an x plus 4 and an x plus 2. But then when we look at the denominator, we're going to get an x plus 2 and an x plus 2. So when you have the exact same thing inside of a set of parentheses, you can cancel that entire set of parentheses on the top and bottom. So this is going to leave you with an x plus 4 over an x plus 2. Now you can leave it like that, or you can wrap the top and bottom in parentheses. If you're used to it, it's fine. It doesn't matter. If you have multiple terms on the top or the bottom, you will need the parentheses, but if it's just one set, you can leave them without. Choice is yours. So, you see where we're going here. I will do one more example with you step by step, and I'm going to save the last 2 for you for this section, and then we will get to multiplying and dividing. So, what we're doing for this is the difference of 2 cubes. So we're going to have our x minus 2 times x squared plus 2x plus 4 for the top. Our denominator, we're going to have x squared plus 2x plus 4, because that cannot be factored. You cannot think of 2 numbers that will multiply to 4 but add to 2, which is perfectly fine, because if you see, we have an x squared plus 2x plus 4 on top and bottom, so those cancel each other out, and you are left with just an x minus 2. All right, so I did the first 4, you do the next 2. I want you to factor the top and bottom if necessary, and I would like you to cancel and simplify the entire thing. Go give it a try. So if you got negative 3 over x for the first one, you are correct. If you factor out a GCF of a negative 3 on the top and then factor, you'll get a negative 3 times an x plus 5 times an x plus 1, because 1 times 5 is 5 and 5 plus 1 is 6. The bottom, you will have the exact same thing after you factor out an x. So your x plus 5's cancel, your x plus 1's cancel, so you're just left with a negative 3 over x. In the second one, the top was the difference of 2 squares, so you get your x plus 1 and x minus 1. The bottom is splitting the middle term, or Batman, whatever you prefer, and you would get your 2x plus 5 and your x plus 1. Your x plus 1's cancel, so you are left with x minus 1 over 2x plus 5, and you're good to go. So that's just simplifying rational functions. We're going to take it a step further by going to multiplying and dividing. Multiplying and dividing are essentially the same thing, as you'll see in just a minute. So let's start with a review problem where we were multiplying with exponents, and just to give you an idea how similar they are. So back in the day when we had multiple exponents like this, we would just multiply across the top. So 3 times 2 is 6, and x squared times x cubed is x to the 5th, and y is all by itself, over 1 times 12 is 12, x is all by himself, y to the 5th times y squared is y to the 7th, And then you would just simplify. So we had 6 over 12, which would reduce to 1/2. We have more x's on top, so we have x to the 4th on top. We have more y's on the bottom, so we have y to the 6th. We are done with that example. Well, we're going to be doing something very, very similar, except for now we're going to have to factor, and we're going to have groups that might cancel, just like the problems that we just did. So for this next example, the first thing you still need to do is factor. So this top can factor to 2 times x squared minus 5 by factoring out a 2. Our denominator cannot be factored, so it's just x plus 1. Times, we have our x plus 2 at the top. Over, and we're going to factor out a 3 here, which is going to leave us with an x squared minus 5 in the bottom. Now, since this is multiplication, you are already good to go. The only thing you have to do is cancel anything on the top with anything on the bottom of either fraction. So this x squared minus 5 will cancel this x squared minus 5. And you don't have to worry about those anymore. So now if anything else could cancel with the top and bottom, you would. Since there isn't anything else, you just write your final answer. In this case, we're going to have 2 over 3. And we have our x plus 2 on top. And we have our x plus 1 on the bottom. And you are done with that example. Division is the exact same thing as multiplication. The only difference is you're going to flip the second fraction. You probably remember back in the day that if we were doing an example like what is 1/2 divided by 3/2, you would just rewrite that problem to 1/2 times the reciprocal of the second, and you would end up with 1/3 after you reduced. Well, this is the exact same concept. You're just multiplying fractions. It's just that these fractions are real big and nasty. So you would factor the top left using Batman or guess and check or splitting the middle term, whatever you prefer. You're going to have your 3x minus 2 and your x plus 1 for the top left. And then you're going to factor the bottom, what multiplies the 2 but adds a 3. You're going to have an x plus 2 and your x plus 1. Now you're going to write multiplication, and you're going to flip that second fraction. So this is actually x plus 2 over 2x instead. And now you go right back to that canceling anything on the top with anything on the bottom. These x plus 1s cancel, these x plus 2s cancel, and you are left with 3x minus 2 over 2x. That's it. You are good to go. So there's one last problem that has a multiplication and a division. That's the last one of the notes, so I'm going to ask you to pause the video and try that big guy on your own. If you can handle that, you're probably in pretty good shape. So pause it and give it a try. If you have x times x plus 2 over 3 times x squared plus 2, you are good to go. Top left, you had to factor out an x, leaving you with x times x plus 11. The bottom left was good to go. You flip the second one, so that's 1 over, factor out your 3, and you have x squared plus 2. The top right was a difference of 2 squares, so that's x plus 2 and x minus 2. Your bottom cannot be factored. But then you have your x plus 11s that canceled, your x minus 2s that canceled, and you just put everything else that's left together. And that's it. This is multiplying and dividing and simplifying rational expressions. And this is also Longo. And I'm out. See you, bye.